Did you have to unmute it?
Yes, I did.
Yeah, they GoToMeeting changed their software so that everybody enters a meeting muted, which I guess if you have a meeting with 1,000 people, that makes sense. But if it's a meeting with one person only, it's not very good. So.
Yeah, true.
So how you doing today, Taylor?
Good. How about you? Just went to homecoming yesterday.
Oh yeah?
Yep.
That's always a life event. I remember both homecomings I went to.
Yeah, it's my first one.
Yeah.
Yep.
Oh, incidentally, thank your mom for the referral.
Okay.
Edito, I'm not sure how to pronounce her name, but she has a daughter taking pre-calc algebra 2, and she told her about me, and she's setting up an appointment.
Okay. I'll let her know.
Yeah, thank her for that. Okay,
Okay.
so we still on Trig?
Yes.
Okay, what are we doing today? Can you verbalize it?
1 second. Just give me 1 moment. I'm just gonna grab my pen real quick. So pretty much, I guess, just continue reviewing what we're doing last week.
Okay. There's going to be one part of trig that will be difficult to verbalize, and that's when you get to sinusoid functions,
Okay.
where they give you a function and they want you to graph it, and then on the other end of that they give you a graph and they want you to write the function. Well, when they give you a graph, that's very difficult to verbalize. So when you get to that part of trig, send me pictures of those graphs.
Okay.
Just take it with your cell phone camera and send it to my email address, and it works perfect. So.
Okay, we'll do it.
Okay. But if it's stuff you can verbalize, it's probably a little easier to just verbalize it.
Okay.
What do you got?
So let me find the problem. Okay, I have one. So cosecant x secant x minus tangent x equals cotangent x.
All right. We don't see any sines and cosines. So to me, that's kind of a clue. I don't know. Let's change that quickly into sines and cosines. What do we have?
So couldn't I get rid of the, the co in there and make it just cosine?
Well, cosecant is not the reciprocal of secant. Cosecant is the reciprocal of sine.
Yeah,
so
sine.
it would be 1 over sine times 1 over cosine, and minus tangent. Well, now it's beginning to look like it does make sense to convert everything to sines and cosines. So I'll write tangent as that. And then what we hope we come up with is cosine over sine, right? Because that's what cotangent is. I guess what I would say here is that because we don't see any squares, we don't see tangent squared or secant squared, I'm going to fall back on converting everything to sines and cosines and not. In other words, there are some problems where that's not the best way to go. But I got a feeling this is not one of them. This is going to be the best way to go. So if I have this, what do I do next?
Couldn't I, or shouldn't I get the same denominator?
Yeah. So what's the common denominator?
Sine and cosine, so I'd have to multiply the other side by sine.
Okay, so we got that now. Now I can turn that into, in other words, just operating on the numerator. What's 1 minus sine squared?
Um, wouldn't it be cosine?
Cosine squared.
Okay,
In other
cosine squared.
words, this is the fundamental identity, but you rarely see it like that. They don't want to make it easy for you. So what you usually see is 1 minus sine squared or 1 minus cosine squared. That's what you have to recognize is the other trig function. So 1 minus sine squared has to be cosine squared. So I can replace that with cosine squared. I can cross that out with the exponent.
That'll just be cosine of your sine.
Which is?
Cotangent.
Did we straighten out how much proof you had to give to the teacher? I mean, did you talk to her about that at all?
She said as long as I just show how I did it, she's okay with it.
In other words, as long as you list every step?
Yeah, because at first I had to get an argument with her because she was saying that she didn't teach me how to do it that way. So she marked them, but then I kind of argued with her because I don't feel that that's right. That
Really?
if I still get the answer correct for her.
She had some problems that you did a way that she didn't teach you how to do, and she was upset about that?
Yeah, so then that's when I talked to her about it, and then that's when she was like, oh, okay.
Wow. I'd be really curious as to which problem it was. Because every one we've done online, I cannot imagine another way. I guess there's always multiple ways to do these things.
Yeah, and I feel that as long as you get the answer right and show your steps, it should not be marked.
Absolutely. Even if you take 8 steps instead of 5, it shouldn't matter. You've still proven that the left side is equal to the right side, and that's the goal. So, okay, what else you got?
Okay, next one I have is, one second. I'm trying to find a good one.
Yeah, find one that you can't do.
Okay. Okay, so far I only have one that I didn't do out of all the ones I didn't do.
Let's do it.
Okay. So this one is, one sec. Okay, secant x over cosine x minus 1 equals tangent squared x.
Okay. The first thing I notice about this is that if I were to add 1 to both sides, I would have tangent squared x plus 1. What does that equal?
So that's the sines and cosines.
Well, no. Now,
oh, secant. No, I now remember. That's secant, right?
Yeah, because I see a tangent squared, we don't necessarily need to convert everything to sines and cosines. If I just added 1, in other words, if that is secant squared, then secant squared minus 1 is equal to tangent squared.
Correct.
So what is this? Is that secant squared? What is cosine?
That's opposite or inverse.
Of? What's the reciprocal of cosine?
Secant.
Boom. That's secant squared.
So I just have to get the reciprocal?
Yeah. If you use the reciprocal of cosine, then you end up with secant squared. And let me just write all the steps. So now we have secant squared of x minus 1 equals tangent squared of x. Well, here's the trig identity. Tangent squared plus 1 equals secant squared. So secant squared minus 1 is equal to tangent squared.
Okay. 1 second.
In other words, this is actually a classic problem where you don't want to convert to sines and cosines. You could, but it would be harder. In other words, you can see that we did it the most efficient way possible by doing one substitution and then getting it to secant squared minus 1. And the key here is to recognize it. In other words, there's a certain amount of pattern recognition involved in doing these. The moment I saw that, I wasn't planning on converting anything to sine over cosine because of the trig identity. In other words, since we know that trig identity, and there's a big 1 sitting out there, it's clear that if I add 1 to both sides, this right side becomes secant squared, which means that better be secant squared. So let's work on proving that that is secant squared. And we do it by converting the bottom to 1 over secant, not the top to 1 over cosine. I mean, I guess it works the same way. If I converted the top to 1 over cosine, then I would have 1 over cosine squared, and that converts to secant squared. So, like I said, there's always multiple ways to go on these things. And that's why your teacher is very correct in letting you do it however you want.
The next one I found was cosecant x minus cotangent x, and parentheses around both of them. Then open parenthesis, cosecant x plus cotangent x, close parenthesis, equals 1.
All right. When you see something like this, one thing should pop into your mind. That is the difference of perfect squares factored. In other words, a squared minus b squared always factors into a minus b times a plus b. Well, you need to be able to go both ways here. In other words, you need to know that that factors into that, but you also, it's very helpful to recognize when you're looking at it factored already, because it makes it really easy to multiply it back together again.
Okay.
So if I'm going to multiply these two things together, and that would be the obvious first step, I don't even have to FOIL it. I know I'm going to get this.
So it's like a quicker way to do it using that.
Right. In other words, you could FOIL it. You know what I mean by FOIL?
Yes.
Okay. You could FOIL it always. But so many problems are difference of perfect squares factored that it just makes it so much easier to multiply it together if you recognize it.
Flows first, outer, inner, and last, correct?
Right. First, outer, inner, and last. But whenever you have a minus b times a plus b, it's always the two middle terms are going to cancel, and you're going to end up with a squared minus b squared.
Okay.
Okay. Now, I can do a couple things here. I can add cotangent squared to both sides and realize that cosecant squared is equal to 1 plus cotangent squared. In other words, here's our identity. So it's a short step to get from there to here. You can do it in a couple of ways. Like I said, I would say that adding cotangent squared of x to both sides, and then just using the trig identity, substituting cosecant squared x with cotangent x plus 1. Now,
Okay.
she could take some exception to that if she doesn't like you messing with the right side.
Mm-hmm.
I could see maybe some teachers don't want you messing with the right side. So let's do it the other way. Cosecant squared x minus, what do we know cotangent squared of x is equal to? It's equal to cosecant squared x minus 1.
Yeah.
That's the identity. Okay, now when you remove the parentheses side, you have plus 1 equals plus 1. And that's rare. I can't think of too many trig identities where you end up with a number equals a number. Usually you end up with trig function, like a trig function. But.
Okay.
Okay. I did post your first session online, and I sent you a link to it. Were you able to find it?
Yes, I got it.
Okay.
Yeah, I got it. Thank you.
Cool. I'll post it to that same link every time, and just look for the file. It's got the initials TP and the date, and that'll be the recording of your file. So.
Okay.
Now, let me just say one thing here. When
Yes.
I do these and it's all one variable, I frequently forget the variable. I don't write it. In other words, I might write this cosecant minus cotangent times cosecant plus cotangent. I would leave the x out. And the only reason I do that is so that I don't have to write x a million times.
Every single time.
Yeah.
But it's implied.
The problem is that you may get to a level in pre-calc where you have two variables. You could have an x and a y, or a theta and a delta, or two things that weren't the same. And then that shortcut's not going to work. You're going to have to put the variable in. You got any other tough ones? I've got some that I can give to you if you want.
Yeah, those work. Yeah, that'll work because otherwise I understand all other ones on this sheet.
Yeah, let me look in my book at the page on trig, verifying trig identities. These tend to, I don't know what textbook you use. Do you have a textbook?
We don't use a textbook, actually.
You have a what?
We don't use a textbook,
Don't use a
actually.
textbook, it's all online? Okay. Well, in my textbook, they tend to get harder as you go deeper into the problems. Here's one that's I've always found a little interesting. Only because of the way it looks. So we have everything in sine and cosine already, but what do we notice? There's a particular expression that you want to recognize always, because it almost always is a clue as to how to proceed.
Okay.
And it's when you have 1 minus cosine or even 1 plus cosine. But assuming we're going to work with this side of the equation, we're looking at 1 minus cosine. Whenever we see that, what's our first natural tendency going to be?
Couldn't I change it into inverse?
Not inverse as much as the
Could I
conjugate.
simplify it into being tangent?
When you see this, 1 minus cosine, 1 minus sine, think multiplying top and bottom by 1 plus cosine, or in this case, 1 plus sine. And the reason being is that that's difference of perfect squares factored, which means it's going to turn into 1 minus cosine squared, which I can replace with a sine squared.
Okay.
Same thing with this. That's going to turn into 1 minus sine squared, which I could replace with a cosine squared. So if you see any of these four terms, whether it's 1 plus cosine, 1 minus sine, 1 minus sine, or 1 minus cosine, think multiplying top and bottom by the conjugate. Okay, so my first step here is going to be to multiply by the conjugate. Of course, I can only multiply by the number 1. So I got to multiply top and bottom by that. Now, what do you get in the top?
Then for the top, wouldn't it be cosine squared?
Hold on. If you're doing difference of perfect squares and putting it back together, always start on the left.
Okay.
So it's 1 minus cosine squared.
Cosine squared.
Okay, that's what the top is. And the key is never distribute the bottom. Whenever you do this kind of a step, always leave it factored.
Oh, okay.
You'll see why. What can I replace 1 minus cosine squared with?
Sine.
So I'm going to replace that with sine squared.
Yeah.
Now I can cancel that with that.
It'll be sine over that.
And I've proven the two are identical.
That's so simple, pretty much.
Yeah. This is kind of a tricky game. It's a bit like a Rubik's Cube. I don't know if you've ever tried to solve a Rubik's Cube or not. But
I have.
there's there's a little bit of pattern recognition involved and things to look for. Usually if everything is in sine and cosine, or even half of the stuff is in sine and cosine, then I'll convert everything to sine and cosine. And I could have solved this a different way. I didn't have to do it that way. I could subtract those two fractions. 1 minus cosine x, and see what I get. And I could add those two things. And that way would work, but it wouldn't work as efficiently. The way we did it was basically a two-step process. And my feeling is that the shorter steps you can use, that's the best way to do it. So if your teacher taught you a 4-step method and you can do it in 2, by all means insist upon doing your method. Okay? And so just because everything starts out in sine and cosine, or even half of it's in sine and cosine, doesn't mean you need to solve it that way. When you spot these kind of patterns, multiply by the conjugate. And that's complete. And the other kind of pattern, let's look at this real quick. Because this is the other identity, then the other thing you want to look for is secant squared minus 1. Because that would be replaceable by tangent squared. Which means if I gave you a problem like secant minus 1 over something equals, again, you want to multiply by the conjugate, secant plus 1. Why? Because you'll end up with secant squared minus 1 in the numerator, which can be replaced by one term, tangent squared. Okay. So if it's secants and cosecants, you're looking for this. Anytime you see one of those three, or one of these four, think, multiply by the conjugate, and you will end up with a term, two terms that can be replaced by one term.
Okay.
All right. Taylor, I have a 3:30, so I'm going to have to run, but
Okay.
hopefully that helped, and I think
I
we
did.
have a session tomorrow at the same time. I'll see you then.
Okay, sounds good. Have a good day.
You too, Taylor. Bye-bye.
Okay.